Hello and welcome to this IGCSE talking paper. Now in this one we're looking at section 2 and that's forces and shape. Let's look at the question. Now this one is a classic question about Hooke's law and extension. So let's read through it together. Student investigates how the extension of a spring varies when he hangs different loads. So it's the classic one looking at extension against load. So here we've got a spring that's going to extend, isn't it? And here we're going to have a load you're going to add bits to. And what you're going to do is be measuring the length of this spring as the load is increased. Okay, so A, write command word, a plan for the student's investigation. Your plan should include details of how the student can make accurate measurements. So there's a clue there what they want. Details about accurate measurements, and you may add the diagram to help you answer. All that's not really required, okay? It's only there if you really want to. Second part, looking at the results, the student finds the spring obeys Hooke's law. I'll hopefully come across Hooke's law and extension now. Draw a graph and axes to show Hooke's law relationship. Okay, this is a sketch graph. You've got no data for this, so do not expect to plot data, but you are expected to label the axes. Okay, label the axes. Okay. Now, the student concludes that the spring shows elastic behaviour, and here, very straightforward, explain what you understand by the term elastic behaviour. So it's a very straightforward question, and what I suggest you do now is pause it, have a go, and we'll back with you again in a few moments. Okay, so let's see what is expected for the plan. So the basic stuff first of all, you add masses one at a time. You could start by saying set of apparatus, that's the diagram you want to. Add masses one at a time. Measure length of the spring. Now we'll see how important that is in just a moment. Then find the extension. Again, I'll come on to that in a moment. Draw a graph with suitable axes. Make sure you mention that. Now detail the spring measurement. Now what that means is where you're taking the measurement from. You're taking it from the absolute top here down to where? You're measuring it to there. Okay, or you measure it down to the bottom of the load. You must specify where your height is going to be from and to. Okay. And how are you going to measure extension? Extension is how much it increases each time. So how are you going to measure that? Okay, so make sure you include that sort of detail. Make sure spring is stationary. When you put masses on there, the spring is going to bounce downwards and bounce up. So make sure it's stationary when you take the reading. Okay, repeat readings. Now, the spring may start to stretch. Now, if you take readings, okay, repeat them as you take masses off. So go down, 100, 200, 300, 400. Then as you go back up, 400, 300, 200, 100. Again, take the extension. So that one's there. And this is one I don't quite agree with. Check valid masses on balance, suggesting the masses you've given are not that accurate. So I'm not sure about that one. Might be that one. Okay. So let's look at how we plot the results. Now, if you know your Hooke's law, you know it is a straight line relationship. So you get 1 mark for drawing a straight line as shown here. Okay, you get a mark for labeling the axes extension on the y-axis and force weight on the x-axis, because force or weight is your independent variable and extension, what you're measuring, is your dependent variable. So you get a mark having put those on, and the third mark is for having your line go through the origin there. Okay, that's the third mark. So 1, 2, 3 marks. There we go, got it. And lastly, what do we understand by the term elastic behaviour? If it's elastic, it returns to its original length when you take the masses off or when the force is removed. So 2 marks. 1 for saying it returns to original length or shape, and second mark for when stretching force is removed. Okay, so 2 marks there. Now don't forget, I hope you can also distinguish between elastic and plastic. You're not asked for plastic here. Just make sure you can distinguish between elastic and plastic. Okay, so most important question, how did you get on? Hope you got 4 marks for that. It's a nice, easy sort of question, particularly if you know your Hooke's law. Okay, so thanks for watching and listening, and back again very soon. Bye bye for now.